think I share your view that any system that self-organizes does so because it is manifesting some form of mentation. I actually think the entire physical universe is just a dashboard representation of mental processes, so to say. So everything has underlying mentation. The question is whether something has private underlying mentation of its own, separate from the underlying mentation of its surroundings or the rest of the universe. So that's what I see as the key question. Where do the boundaries lie? Where can we say, okay, this system now has a private conscious inner life that is coextensive with the boundaries of its body or its structure? And that's where I question whether we can speak of private conscious inner life for an inanimate object, because those objects tend to be so nominal. But regarding the electrons, there I depart from you, and not because my core intuitions differ from yours. I don't think they do. But, in quantum field theory, which is the relativistic extension of classical quantum theory, we need quantum field theory to explain nature, because it's the only theory that explains the interactions between particles. Classical quantum theory has nothing to say about how particles interact. According to that theory, the only way to account for a great many things, including inertia, is to regard particles not as things, not as entities with spatial boundaries, but ripples on the underlying field. There being nothing to the particle but the underlying field, just as there is nothing to the ripple on the lake but the lake. You can't fish the ripple out and carry it home with you. It's an expression, it's a behavior of the lake. It's something the lake does. But the only thing is the lake, not the ripple. And in the same way, under quantum field theory, and even many physicists, particularly solid-state physicists, don't seem to be explicitly aware of it. Under QFT, there are no particles. Particles is shorthand for a transitory field excitation. It's not a thing, it's a doing of the field. And without this understanding, we couldn't explain, for instance, quantum fluctuations. They would be magical. Real things would pop into existence out of nothing and disappear into nothing for no reason. Well, we account for that by saying particles are just ripples on the lake, and sometimes the ripples die down and sometimes they come back up. We wouldn't be able to explain particle decay. A Higgs boson can decay into a pair of muons, but there are no muons in the Higgs boson. So it would be magical. The Higgs boson would disappear into nothingness and two muons would appear out of nothingness. But if you understand that the Higgs boson is a ripple in the Higgs field, then that ripple can decay and give rise to different sub-ripples because in the process of losing energy. And finally, even inertia, we explain inertia through the idea that, and this is a metaphor, it's not really accurate, but it's the best one can do briefly. The idea of inertia, why does mass resist changes in speed, in the direction or the amplitude of speed? Why does mass resist acceleration? It's because there is a Higgs field that is kind of sticky, and therefore it takes a lot of force to get something to move in that sticky field. Without it, the Higgs boson does not explain inertia. But the understanding is the Higgs boson is just a manifestation of the Higgs field. The boson itself is irrelevant. It doesn't explain inertia. It's the underlying field that does. And to say that an electron has a private conscious inner life of its own would require that it be a true entity with discrete spatial boundaries, while we have a lot of reasons to not think of it that way. If you want the electron to have consciousness, then you need the electromagnetic field to have consciousness. And that is as large as the whole of existence. It doesn't have spatial boundaries.